And we're back for our second video, ratio and root test. We'll talk about ratios. So there it is one more time. Where we're going to take the next term divided by the previous term. Take the limit as k goes to infinity. Make sure to use an absolute value. And if the ratio r turns out to be less than 1, it's absolutely convergent. If it's greater than 1, including infinity, it's going to be divergent. If it equals 1, then we can't say a gosh darn thing. So let us tackle a problem. So here's going to be our game. We see the factorial, you're really going to want to think ratio. You see a factorial, that's the first place my brain goes to. I'm like, I'm going to start with ratio test. There's other ways of solving these things, but ratio test is a good one. So what is our a sub k? Well, our a sub k is just this 10 to the k over k factorial. And then what's our a of k plus 1? Well, it's 10 to the k plus 1 over k plus 1 factorial. So everywhere we had a k, we just changed it to k plus 1. Now what it says our ratio will become, r is equal to the limit as k goes to infinity of the absolute value of a sub k plus 1 divided by a sub k. Trying to see if the next term is going to be bigger than the previous term. So we're not going to write the absolute values. That's only going to cause confusion. Everything is positive here. So we put our a sub k plus 1 up top. There's your 10 to the k plus 1. 10 to the k plus 1. Do you see it? Do you see it? Do you see it? Sorry, I just wanted to pop that one in there. Did you know 10 to the k times 10 is 10 to the k plus 1? I hope so. And then we get 10 to the k over k factorial. Well, let's do our flip it and hit it, or invert it and multiply. We're like, okay, so it's the limit as k goes to oops, I'm thinking about them factorials. So we have 10 to the k times 10 over k plus 1 factorial times, and now we take our denominator and we flip it and we multiply, or invert it, right? Got to get all fancy with it. And now we want to see where this limit's going to go. Well, first thing is nice is the 10 to the k's are going to go away. Now we're going to need to deal with those factorials. So we need to play the same game as what we did in our previous video, except now there's going to be a 10 inside of here. So you have 10 times k factorial over k plus 1 factorial. Do you see that it's just going to end up with a k in the denominator? If not, no biggie. We're just learning it. Let's go. So this is 10 times 1 times 2 times 3 times 4 times ... k minus 1 times k. Oh, there it is. We got it. I don't know why I used that. Parenthesis. And then down below, we're going to have 1 times 2 times 3 times 4 times ... And we're going to have our k minus 1. We're going to have our k. And we're going to have our k plus 1. Then we cancel. So what are we left with? We are left with the limit as k goes to infinity of 10 over k plus 1. Now, the degree of the bottom is 1. The degree of the top is 0. We're taking a limit as k goes to infinity. Thus, this goes to 0. So we found out r is equal to 0. Our r is equal to 0. We go pop back up. We look, and we're like, if it's less than 1, the series converges out. Oh, okay, so it converges absolutely. There we be. That's the ratio test. Let's try another. Delete that, and let's go. Okay, oh, more. Uh-oh, we have k to the k. We got a negative 1 to the k. Uh-oh. Now, at this point, see, if you learn that which sequences grow faster trick, I look at this and go, whoop. K to the k grows faster than k factorial. This diverges. And you can do that on a test. If you saw it and you're like, nah, that diverges. Sure, go for it. But if you mess up, you won't get any partial credit. But that's just a knowledge thing. I know walking into this thing, like for sure, I've never done this problem before in my life. Well, I probably have in the past. I just don't remember it. But I don't know how this is going to turn out. I'm just looking at it. I try not to know what the answers are going to be before I start, because I want you to see me struggle a little bit, just like y'all struggle. But I'm guessing this diverges. K to the k grows faster than k factorial. Okay. Oh, let's check it out. So we got to find our a sub k, but let's do it this way. Let's call it the absolute value, which means just lose the negative 1. And then we're going to find our a sub k plus 1, which is going to be k plus 1, raised to the k plus 1, all over k plus 1, factorial. Yeah, buddy. Let's go. Let's go. We got this. This isn't that big of a deal. We can knock this one out. Okay. So now we're going to say our ratio, our R, is going to be the limit as k goes to infinity. Now, I'm not going to write the absolute values. There's no need. Look, both of them are positive. So we get k plus 1 to the k plus 1 over k plus 1 factorial divided by k to the k over k factorial. Wow, that's a lot in there, isn't it? And if you try and see it, help me solve it, it'll just be like, clearly this is k plus 1 over k, all raised to the k. All right, I'm checking that out. So let's flip it and invert it. Oh, I said the same thing. So k goes to infinity, k plus 1 to the k plus 1 over k plus 1 factorial times, and then we get our k factorial up top and our k raised to the power of k. Y'all ready for this? Here comes some algebra for y'all. Okay, this is equal to the limit as k goes to infinity. So I'm going to leave this k to the k. I'm going to put this one. I'll put that out front. I think that's good to go. I don't want to mess with that. And then we're going to have our k plus 1 factorial, which is 1 times 2 times 3 times dot, dot, dot. K minus 1, k plus 1. There we go. We handled the denominator. That's the simpler one of the two. And now I think I'm just going to write in the k factorial next. Up top, 2 times 3 times dot, dot, dot. K minus 1 times k. And then lastly, we're left with this k plus 1 to the k. But I think I'd rather write this k plus 1 to the k times k plus 1. Right? Then we add our exponents. We do. So now let's cancel some stuff out and let's see what happens. The 1s went, the 2s went, the 3s went, the k minus 1s go, the k's go. Oh, look, k plus 1 and a k plus 1. The only thing I think we're left with here is a k plus 1 to the k and a k to the k. Yeah, buddy. That means we're getting somewhere. So we have k plus 1 to the k over k to the k. Oh, wait, they have the same exponent. Both their exponents are k. So this is equal to the limit as k goes to infinity of k plus 1 over k raised to the power of k. All right, now go do that limit. Where's it go? Where's it go? I got to do just one step here. I want to break up that numerator real fast. So we get k over k plus 1 over k raised to the power of k. But k over k, I'm just going to cheat and write it in as 1. Oh, that equals e. Do you recognize that pattern? Hopefully your teacher did this with you in Calc 1 and showed you that there's a pattern. Oh, I've shown you, talked about it, 3, 4, 5, 6 times now. So you can do L'Hopital's on this, go through and do all the work, or you can recognize it. I prefer to just recognize it. So what does that say about our problem? Well, our R is equal to E, which is greater than 1. That's the rule. If it's greater than 1, then we say this diverges. Hey, wait, that was my guess at the beginning. Just because I knew k to the k grows faster than k factorial, so it was a pretty good guess. You're not always going to be right on your guesses, but I don't know, I'm feeling pretty proud of myself right now. Feeling pretty cool. All right, 10 minutes in. We got one more problem to do in ratio. Oh, goodness. Oh, goodness. I'd like to write this differently right off the bat, though. I see a negative exponent. I'm like, bro, I'm not dealing with any negative exponents. I want to see what's going on. We got negative 1 to the k plus 1. I like to just leave that out to the front. We got k squared plus 4 over e to the k. I'm going to kind of separate those two things out. That negative 1 to the k plus 1. Cool story. Yeah, we're going to ignore you. You're not even going to be part of this. Now, I'm just looking here, and I'm like, I wonder what grows faster. A square or the exponential function? It's probably all lies I've been told about things growing exponentially, like that's fast or something. Yeah, so I'm guessing right off the bat, this will converge. That's just my guess. I don't know if I'm right. I'm pretty freaking sure I'm right. All right, so let's write it on our a sub k squared plus 4 over e to the k, and our a sub k plus 1, which is going to be k plus 1 all squared plus 4 over e to the k plus 1. Okay. Let's go. Now, there might be some stuff you want to do here, and I'm actually going to start doing this now. I'm going to start simplifying down stuff before I go throwing this in the problem. Like the denominator, that's e to the k times e. Then I'm going to expand this thing out. Down at the bottom, k plus 1 all squared is k squared plus 2k plus 1. And now I'm going to cheat. I'm going to do 1 plus 1 is equal to positive 5. There we go. This is a little more mellow to deal with, you know? That's a little better. Doing our work outside the limit, because we're about to have to do our ratio. We're going to say, all right, now r is equal to, the limit is k goes to infinity. Oh, and these are absolute values. My bad. I like to do the absolute value at the beginning. So we're going to put our a sub k plus 1 up top. So k squared plus 2k plus 5 all over e to the k times e over k squared plus 4 over e to the k. I remember being a student, I wouldn't even write this step. No. I would just jump to the next, knowing that denominator is going to get inverted and multiplied. It's like, why write a step that you know exactly what's going to happen? All right? Because we're just going to come to this point now. It happens the same way every time. Do enough of these problems and it won't be that big of a deal. So we look through and we're like, hey, there we go. Boom, boom. E to the k's go away. And now we want to tackle that limit. But we still have this e hanging out. So I want to rip that out, that 1 over e. Notice how it's in the denominator? So we got limit of k goes to infinity, and we got k squared plus 2k plus 5 over k squared plus 4. Now, we are not in Calc 1 anymore. I know I'm a broken record. But we just look at, it's a degree 2 over a degree 2. So all it is the leading coefficient. So we're going to get that this is 1 over e times 1, which is 1 over e. So our ratio is 1 over e, which is 100% less than 1. 1 over e, 1 divided by 2, 1 divided by 3. You know e's in between 2 and 3. It's still less than 1. Therefore, this converges absolutely. Got it. So that is how our ratio test is going to work. Ratio test is one of the more used for myself. As soon as I see one of those factorials, my brain starts thinking ratio. Now they can pop up in other spots, but you got to have some sort of hierarchy as to how you're going to do things. So there it is. We're going to move into the root test next. Root test isn't all that bad in comparison. So, yeah, buddy. See ya.